All right, we're back. More piecewise stuff. This time, let's write the function. And so, in writing the function, the first thing I usually do is write the boundary points. And so, this one goes from -4 to -2. And it's important that you keep the open circle and closed circle in mind when you're writing it. So it's allowed to be equal to -4, but not equal to 2 in that first function. The second function goes between -2, -2 and +3. And the last function goes between +3, and then notice the arrow, so then that goes on forever. So x is just allowed to be greater than or equal to 3. And again, the equal comes in from the closed circle. So now it's a matter of putting the functions in. And depending upon the way the graph is drawn, depends upon how easy it is to figure out the functions. Now, this case, and I'll show you the different types as we go, but this case here, if you follow it along, we notice that we can find the y-intercept just by dragging it through. So this line has a y-intercept of -1. And if we look at the slope, this line goes up 1 and right 1. So it would have a slope of +1. That's the easiest one to write because it's already in y equals mx plus b form. So the function would just be 1x minus 1, and then we're done. Okay? You don't need the 1 if you don't want to write it there. All right, the second one's a horizontal line, and so that one just depends on which number it's going through. It's going through +2, so the equation would be y, or f of x, just equals 2. The last one's a little trickier. We could probably play around with it and figure out where it hits, but this one I'm going to do through the 2 points. So here's a point at 3, -3, and this will also give you more practice with writing equations. Then you just need any other point on the line. I'll use the intercept where it goes through, and that point is 0, 4. And then let's find the equation of that line. So the slope would be 4 minus -3 all over, whoops, sorry, I knew I did something wrong here. This point is backwards. This should be 4, 0. All right, let's redo it. So the slope is 0 minus -3 over 4 minus 3, which would be 3 over 1, or just 3. Okay, now to go ahead and find the y-intercept, we know we have this equation, y equals 3x plus b. Take one of the 2 points and plug in or substitute x and y in. So let's use 4, 0. So y is 0, x is 4, and we end up getting b as -12, which we can probably kind of see as this goes down. It's going to hit way down here, so -12 does seem reasonable. So then the final equation would be 3x minus 12. And there's that function. All right, let's try one more. All right, same thing. Let's do the boundaries first. And so I'm going from -4 and, in this case, -2, but notice there's an arrow there, so that goes on forever. So we've got x is less than -2. The next one goes from -2 to 0, and it's allowed to be -2, but not allowed to be 0. And the last one goes from 0 to 3, and this one is allowed to be 0, but not allowed to be 3. So let's do the functions. We have a few different ways here. Let's do the first one with 2 points, even though, again, I think you can find the intercept. So we've got this point is -2, -1. This point is -6, +1. So we get a slope, -1 minus 1 over the -2 minus -6, which would be -2 over 4, so -1/2. And then, so to find the y-intercept, we take one of the 2 points and we substitute it in. So -1 equals -1/2 times -2 plus b. And then if we solve for b, we get b equals, this would be 1, so -2. So then the first equation would be -1/2 x minus 2. And the second equation, this one, we have the y-intercept, so we know the y-intercept is 4, and the slope, we can just count it out. So up to right 1, so the slope is 2. So we get 2x plus 4. And the last one, we have the same situation. We have the y-intercept, and we can count out the slope. Down 1, right 3. So that slope would be -1/3. And so the last line is -1/3 x plus 2. All right, and there's graphing the lines. Or sorry, writing the equations.